Okay, today we are diving into a very powerful part of programming, loops. Loops are our tools for repeating actions. In Python, we have two main types of loops, for and while. To understand their difference, let's imagine this scenario. Imagine we have two delivery motor skills. Both of them can only move one box at a time. First, the rate motor skill, the for loop. The rate motor skill is our for loop. Its task is very specific. It has been told you have exactly 10 boxes in front of you. You must go and move them one by one. The rate motor skill knows in advance that its job will be finished in exactly 10 steps. After moving the 10th box, its task is complete. The number of repetitions is known. In summary, a for loop is like the rate motor skill. We use it when we have a defined collection, like a list with 10 boxes, and we want to do something for each box in that collection. Second, the blue motor skill, the while loop. The blue motor skill is our while loop. Its task is a bit different. It has a stack of boxes in front of it, but the total number is any noun. The rule is as long as there are still boxes in this location, keep moving them. The blue motor skill doesn't know in advance how many steps its job will take. After moving each box, it asks a question. Are there any boxes left? If the answer is yes, it continues. If no, it stops. In summary, a while loop is like the blue motor skill. We use it when we don't know how many times we need to repeat a task, but we want it to continue as long as a certain condition is true. For example, while there are boxes left. An important note. We could also tell the blue motor skill stop after you have moved 20 boxes. This shows that you can sometimes use a while loop for a task that a for loop could also do. However, for defined countable tasks, the for loop is often simpler and cleaner. From this, we can understand that for loop is naturally used with collections like lists, tuples, and dictionaries, because with those, we know the boundary of our task. Welcome to our practical session on the for loop. Remember, the for loop is our rate motor skill. It's designed to go through a collection of items one by one when we know exactly how many items there are. Let's start by looking at the basic structure or syntax of a for loop. The syntax is very simple and readable. It looks like this. For item underscore variable in collection. Remember colon. This is the intended block of action. This block will run once for each item for and in. These are required keywords. Item underscore variable. This is a temporary variable that you can name anything you like. In each loop, it will hold the current item for the collection. Collection. This can be any sequence or collection like a string, a list, a tuple, or a dictionary. Now let's see how this works with different data types using very simple examples. I will create a new file named loops.py. First, looping through a string. A string is a collection of characters. A for loop will go through it one character at a time. For example, my underscore string equal to Sarah. For character in my string, colon, remember colon, it means new indented block, print character. For each character in the my string, do this action. Loop through a list. This is the most common use case. The loop will process each item in the list one by one. For example, my underscore books equal to math, art, physics. For book in my book is print book. Read this as for each book in my books list. Looping through a tuple. It works with tuples in the exact same way as lists. For example, my underscore locked bundle equal to 10, 20, 30. For number in my locked bundle, print number. Read this as for each number in the my locked bundle. Looping through a dictionary. Looping through a dictionary is a bit special. By default, a for loop will iterate through its keys. For example, library underscore catalog equal to math colon green book, art colon orange book. You know, math and art are keys and colors are values. For subject in library catalog, print subject. Read this as for each subject, we can say keys here in the library catalog. If you want to get the value, you can do this. For subject in library catalog, print library underscore catalog, subject between two square brackets, we write key. Think subject is a key, yeah? As you can see, the for loop is a powerful and flexible tool for working with any type of collection. Now that you understand the basics, you are ready for a more special challenge. Let's start with a real-world problem. Imagine we are working in the HR department, and our task is to give every employee a 100 bonus. We have a list of all the current employee salaries like this. Now we could do this manually, one by one, repeating the same process. For example, 1,500 plus 100 equal to 1,600. 1,250 plus 100 equal to 1,350, and so on. But this is repetitive and inefficient. Instead, let's use the powerful tool that programming gives us for repeating an action. And this brings us to a question. Which our two motor skills should we use for this loop? Should we use the blue motor skill, the while loop, which works as long as a condition is true? Or should we use the red motor skill, the for loop, which is designed to go through a collection of items one by one? Let's think. We have a defined collection of items, the list of salaries. We want to do something for each salary in that list. The number of repetitions is known. It is equal to the number of employees. This is the perfect job for the red motor skill, the for loop. Let's apply this to our problem. For example, employee salary equal to list 1,500, 1,250, 3,000, 1,750, 3,250. New salaries equal to empty list, an empty list to store the new salaries after adding the bonus. For salary in employee underscore salaries, this is our loop. Read it as for each salary inside the employee salaries list. Colon. It means this intended block of code will run once for each item in the list. New underscore salary equal to salary plus 100. Calculate the new salary for the current employee. New underscore salaries dot append function new salary. Do you remember append function? It is a special function for lists. Add the new salary to our new list. Print original salary, new salary. In Python, when we write a variable inside the string, we use double curly brackets like this. This dollar sign represents the type of currency. And outside the loop, we write final result, print final result, print original salaries, comma, employee salaries. This is the old list. Print new salaries with bonus, new salaries. This is a new list. Okay, so you have learned how to perform the same action for every employee. But what if the rules are more complex? What if you only want to give a bonus to some employees based on a condition? This is where we combine the power of two of our most important tools, the for loop to go through the list and the if statement to make a decision for each item. Scenario number one, conditional bonus. Think the manager now says, only give a £100 bonus to the employees who have a low salary. Let's assume a low salary is anything less than £2,000. How do we solve this? Inside our for loop, for each salary, we will use an if statement to ask a question. For example, employee underscore salaries equal to 1,500, 1,250, 3,000, 1,750, 3,250. New underscore salaries underscore conditional equal to empty list. This is to includes new results. For salary in employee underscore salaries, if salary less than 2,000, here is our decision point inside the loop. We ask, is the current salary less than 2,000? If the answer is true, we add the bonus like this. New underscore salary equal to salary plus 100. Print low salary found. Salary adding bonus, new salary variable. Else, if the answer is false, we do nothing and keep the original salary. Like this, new underscore salary equal to salary. Print high salary found. Salary variable, no bonus added. We add the result either with or without the bonus to our new list. Like this, new underscore salaries underscore conditional dot append new salary. And now outside the for block, we print final condition salaries, new salaries underscore conditional. Scenario number 2, differentiated bonus. Now the manager has a new rule. Give a 100 bonus to low salary employees, for example, less than 2,500, but give only a 50 bonus to high salary employees. This requires a full if-else structure inside our loop. For example, employee underscore salaries equal to new underscore salary differentiated equal to empty list. For salary in employee underscore salaries, if salary less than 2,500, we ask the question, is the current salary less than 2,500? New underscore salary equal to salary plus 100. This is the if block for low salaries. Print low salary variable gets 100 bonus, new salary. Else. The else block for high salaries. New underscore salary equal to salary plus 50. Print high salary gets 50 bonus, new salary. New underscore salary is differentiated dot append new underscore salary. Print final differentiated salaries, new salaries differentiated. This is a very powerful concept. By placing an if statement inside a for loop, you can process a large amount of data and make a unique, intelligent decision for every single item in that collection. This is a fundamental pattern you will use throughout your entire programming career. And with that, I want you to take a moment and realize what you have just accomplished. Congratulations, you have done something incredible here. With just a few lines of code, you have built a small program that can process the salaries for millions of employees in less than a second. This is the true power of programming. Taking a complex, repetitive task and automating it with logic. The skills you are learning right now are the foundation for solving very big and important problems.